Our speaker today, who is none other than Professor Dr. Bhuvan Unhelkar from University of South Florida. Professor Bhuvan Unhelkar has more than 2 decades of strategic as well as hands-on professional experience in the information and communications technology industry. Dr. Unhelkar currently leads the IT department at the University of South Florida, Sarasota Manat campus. As a founder of Method Science and Platify, he has demonstrated consulting and training expertise in big data, business analysis, software engineering, collaborative web services, green IT, and mobile business. Dr. Unhelkar's domain experience includes banking, financial, insurance, government, and telecommunications. Dr. Unhelkar has designed, developed, and customized a suite of industrial courses which have been regularly delivered to business executives and IT professionals globally, including those in Australia, US, UK, China, India, Sri Lanka, New Zealand, Singapore, and Malaysia. He is also a specialist distance tutor for the Australian Computer Society and Australian Catholic University. Dr. Unhelkar's thought leadership is reflected through multiple Qatar executive reports, various journals, and 21 books, including Big Data Strategies for Agile Business and The Art of Agile Practice, a composite approach for projects and organizations, to name a few. With these words, may I now request Dr. Unhelkar to kindly take over and address the audience. Welcome, sir. Over to you, sir.
Thank you. Namaste to all my friends. Good morning. It's a late evening here in Florida, where I'm sitting. But it's a nice, bright morning in India. And I am delighted, I am honored to be invited to share these thoughts with you. I will now start sharing my screen, and I believe I have been given approximately 45 minutes, and I plan to stick to them or even within the time given. And I also wish everyone safety and well-being during these, very horrid times that the world is facing. So this is the brief that was given to me, and today I thought I will share with you some ideas around the work I'm doing here, along with a few co-researchers. My wish is, of course, that this will inspire some of our young minds to explore the domain of environmental intelligence. Thank you for a very nice introduction, sir, and also to everyone in Sharda University. We just had the Vasant Panchami festival, not that we celebrate it here in America like the way we do in India, but that is Goddess Saraswati's festival, and Sharda is her name, so I'm glad to be addressing the institution that is named after her. My resume has been slightly updated now, and I have a few more books to my name, one of which is Artificial Intelligence and Business Optimization. And my goal currently is to apply those data science thought processes to the environmental domain. I am not new to your university, and it was a few months back that I was on the panel discussion, so I thought I will thank especially Professor Ankur Chaudhary, who has been a very good contact, very nice person who has been very kind in inviting me to your university. way back somewhere in 1996-7, I completed my PhD in the area of object-oriented software modeling with Professor Brian Henderson Sellers, and that has continued with me up to now. But current research interests are cybersecurity and environment and sustainability. So these are some of my books, just always proud to show them off. They are now freely available to all my students in University of South Florida. So the idea is to share the knowledge rather than make it into a business. Uh, this particular article, Psychology of Agile, in fact, today itself I received the confirmation from CRC Press that this article or these executive reports are now going to be converted into yet another book that will be of value to consultants. And this is also a textbook I'm using. UML is still of value, unified modeling language, even though young programmers might be keen to learn Python, and we do teach Python, and we occasionally teach R, and of course Java is stock standard. But at the same time, modeling with UML has its own value, tremendous value in producing good quality software solutions. These are some of my other books. You may find some areas interesting, in which case you are welcome to reach out to me. You're all welcome to connect with me on LinkedIn, as I always see in all my presentations. And this is the work I have done in the past, in fact, over last 10 years, that is relevant to what I'm talking today, which is developing a environmentally responsible business strategy. In fact, this particular book, edited book, is in two parts and of made up of 60 chapters, whereas the Green IT Strategies and Applications is a single authored book. I also did some work in green IT metrics and measurement. And again, some of you, especially students, might have a bent of mind that is more statistical than others, and you may want to consider dealing with green IT metrics, because that's extremely interesting and very, very complex. And again, one more article. And there is a lot of work I'm doing right now with various fellow researchers. In fact, my sabbatical for entire spring semester next year has been approved. So from this December till May, June next year, I'll be fully focusing only on research. My campus dean, Dr. Jan Cabango, and I are working on a literature map of big data and sustainability, which is my current, one of my current journal papers, and then there are a few more. And I'm also putting together a foundation grant. Never sure if we will get it, but it is something worth trying in this particular space, which is environmental sustainability. This is the high-level sketch of the grant, and it is inspired by what has happened during COVID-19, and I will take you through that. There is a certain intellectual value in it. I have outlined a high-level approach and a definite impact on business and society. Since all of us around the world are always following what's happening in the US, in addition to people like me always following what's happening in India, with the change in administration, there has been a renewed focus on the environment. And as you know, US has entered the Paris Accord once again and renewed various commitments to environment and sustainability, which is good for the kind of work that I and many of my fellow researchers are planning to do. So the background thinking, COVID-19 has inspired it. I had done some work in the past, but then we thought that, especially over the last 4 years, that environment has no opportunity to be renewed. And suddenly we find that no, COVID-19 has actually put a renewed focus on the environment. So let me take you through that thought process. India, Australia, US, Europe, every country has been under a lockdown. And then, depending on how they want to handle the pandemic, there are rules to relax that particular lockdown. So, one very important thing that happened during the COVID-19 impact was shutting down of traffic, shutting down of airlines. In fact, right now I am sitting in Florida and my family is in Sydney, Australia, and I cannot travel there. Um, I mean, I can, but only in a worse situation. So airline traffic has gone down. There are no Qantas and New Zealand Airlines flying into the US. So with this lockdown, the question is, did it have any impact on carbon emissions? And if it did, to what extent was the impact there? These are all very interesting data science questions. And as I told you, my work in data science or AI, artificial intelligence, I'm trying to bring it into the area of environmental intelligence. So we have some interesting questions. And the initial thought process around the world was that with reduction in traffic, with the lockdowns, not only road traffic, but air traffic and so many other mechanisms of producing carbon have been shut down. Have we really reduced carbon emission? So a simple question which this cartoon very nicely depicts is this particular conference, this particular keynote, if I was to deliver this in a pre-pandemic era, I would be physically there giving this talk. But right now I'm sitting here and I have saved the carbon emissions that would have resulted only a fraction of the entire flight. But it has reduced those carbon emissions. And there are so many of you, students and other interested faculty members who could be listening to this talk in the comfort of their home without having to travel. Has that reduced carbon? And look at this cartoon. In the first half, the person feels, oh, I am producing carbon because I am burning diesel. In the second, the person feels I'm using electric car, so I'm not burning diesel, and so I am clean. But in the background, there is a shift in the emission from the individual car to a whole plant that is producing much more electricity now. This particular talk over Zoom is also producing carbon, but it is not visible to you and I, but only where the Zoom server is located. So, an interesting research question that I'm trying to pursue in the overall environmentally responsible business strategy is how much of carbon emission has shifted from the point where the consumption used to happen earlier to where the energy is being produced now. Is there a real reduction or it is simply a shift of emission from one place to the other? That is the fundamental thesis of the study that I am trying to move forward with, and that I wanted to share with all of you. Kaggle, of course, contains a few databases. I tried to check on environment and sustainability. So those students who are in the big data space, in the artificial intelligence space, and want to apply it to the environment are encouraged to visit Kaggle. And we can also create our own databases. We should, in fact, create our own databases based on surveys and other mechanisms of measuring emissions. So how do we understand environmental intelligence? It's really application of artificial intelligence to the environmental problem, which starts by measuring the carbon footprint of an organization, of a device, of an individual. So when it comes to even buying a car or a laptop or a fridge or a microwave, along with the price of that particular gadget, it is also necessary for the manufacturer to put the amount of carbon that was generated in producing, in developing, in manufacturing that gadget. So that's the mechanism, or that's the metrics that we need as we start moving towards measuring the carbon footprint. Because once we measure the footprint, then we have the opportunity of reducing it or controlling it. So it can be understood, that is EI, as the use of data by an organization's systems, processes, applications, storages, contents, architectures, and designs in order to implement environmentally responsible business strategies. The important thing here is it has to be a responsible business strategy. That means, the most ideal way to reduce carbon emission is to shut down a business. But it is not ideal in true sense of the word, because that would be irresponsible. And therefore, we need a balancing act. And that is where the higher level or the umbrella thesis of my work is, which is there is a motivation for businesses to reduce their emission, and that motivation primarily comes from desire for profitability, whether we like it or not. And that can be a good starting point, something that can be justified in developing ERBS. So I mentioned carbon data, then measuring the carbon footprint of the organization, which will help us also measure the carbon footprint of producing a device like a car or a microwave, or offering a service like staying in a hotel or being admitted as a patient in some unfortunate situation. It also produces carbon. And then we move towards the industry. So from an organization's footprint, we move towards industry footprint. And finally, carbon efficient society. That's an area I have not touched. But if there are students, researchers who are overlapping the socio political aspects of carbon with the technology aspect, then that's an area for them to research. One of my past PhD students, Dr. Bharati Trivedi, who is in India right now, has created this pyramid, if you like, of how from recalibrating business strategies due to COVID-19 crisis, we are moving higher to an overall business strategy that will not only reduce carbon, but will also enable profitability and better market image for the organization. So a lot of material has gone in here, but if you look at the right, it's on the right hand side, it's calibration, innovation, optimization, and then overall intelligence, which is ongoing and matured optimization for business processes. And another keyword that I would like to stress is holistic. There is no point in taking a small part of the organization and saying this is the one that is going to be more green, or this is the one that's going to emit less carbon. It has to be holistic. And the measures that we put together should cover the entire organization for a reasonable period of time, that is duration, and with substantial iterations, which is intensity. So on the right, you see these three words being written. Now, I already mentioned that COVID-19 produced a unimaginable situation, which is lockdown, which reduced traffic, air, land, and sea, and therefore carbon emissions. Um, there are many friends, particularly my friends from the north, from Delhi and further north. In fact, friends from Patiala and other places in Punjab were telling me now they can see the Himalayas, which they never saw, which is I think 200 kilometers distance, because of the lockdown. This was of course last year, March, April, May. So the question is, has really the world benefited by the lockdown? The research question is that, and of course we have to, uh, collect data. We have to analyze data, and the important, the crucial discussion on whether it has simply shifted rather than reduced is the question to be answered with the help of data. I've done some work pre-COVID along with another friend of mine who is not a researcher from an academic viewpoint, a practitioner instead, Graham Phillipson. And we had identified this framework in which attitude and the policy of the organization and the best practices and the technology support and measurement were all important background factors in enabling an organization to become green and increasingly green. And then, of course, equipment, users, enterprise data center, and use of IT as enabler were also highlighted. So if that is environmental intelligence in a business term, then the question is, how do we start applying it in order to develop this environmentally responsible business strategy? And here is some, stock standard MBA management stuff that we start with the individual and we go up to the policies, and it can take up to between 5 to 8 years for the society to be impacted through the government policies. Now, the policies in the work that Dr. Trivedi and I had done, we discovered that the policies at uh, organization, industry, and government level, that is society level, are all impacted by a underlying factor, and that is, typical capitalistic approach, profitability. So the underlying reasons for greening or environmentally responsible behavior seem to be still a desire to increase the revenues in an organization. And to if that desire to increase revenue goes unchecked, then carbon and so environmental responsibility gets thrown out. And when governments step in, especially Australia and New Zealand are world-class examples of government stepping in and impacting, influencing the behavior of corporates. Government rules and regulations, especially penalties associated with excessive carbon emissions, played a major role in the development of a good holistic strategy. There are more data, and you can see some of that data is being shown over here. Government rules and regulations, um, environmental policy goals, increase revenue seems to be very, very popular. Meet government rules and regulations, improving the reputation of the organization, reduction in operational cost, which is optimization, which is use of data science for business optimization, and so on. So if that is the goal, what are the factors that are going to influence the strategies? So having senior members responsible in an executive body, costs that are going to be incurred in additional cost in order to implement green initiatives, alternate sources of energy, implementing monitoring method, which is metrics, government regulations, and use of ICT in minimizing the environment's footprint. So that last bit is also an area of great interest from a research and practitioner's viewpoint. ICT and typically huge data centers, which of course companies themselves don't own. Now it's all owned by Amazon or Google or Microsoft, or any of these large service providers. But can ICT be also used to minimize the footprints? And of course, the answer is yes. So ICT is supposed to be responsible for producing more carbon, the data centers, but ICT can also be used to reduce the emissions. And strategic plans, this is a old data, um, can be revised, should be revised, but still speaks volumes in terms of the need, like how can we achieve those plans. Methodology to undertake defensive power consumption and creating power management policies came out on top when we had done this work almost a decade ago. And then anticipate changes to government regulations, improving your risk management and enhancing human resource management. In my talk thus far, I haven't talked much about people and attitude, except mentioning it once in one of the frameworks, but it does play a major role. And I'm in touch with Professor Abhay Saxena at Dev Sanskriti University up north in Haridwar, and a phenomenal amount of work he's doing. He is a IT person, but he is doing work in sustainability based on some of the ancient Indian practices and Indian lifestyles. And I think the time is right globally for some of those practices to be brought into environmentally responsible behaviors. So I talked about environmental intelligence, and then I talked about the motivation for ERBS. I also talked about the fact that COVID-19 induced lockdown suddenly made us realize that there is less carbon, and then it also made us realize, really, is it really less carbon or it is shifted carbon, which is the thesis of the study that I'm doing. But when it comes to the business and the motivation of the business, we still find profitability is an important motivator. So now if we have to develop the environmentally responsible business strategies, we have to, okay, COVID-19 has induced the responsible behavior, thought processes, but then it comes to costs, then it comes to new market opportunities due to reduction, uh, due to the demand for reduction in carbon emission, social and political pressure, especially younger folks. I know in my family, my children who are grown-up children are super conscious, super aware of environmental issues than I ever was when I was their age. Governments are, of course, legislating, and the penalty processes of the government in the Excel spreadsheet that an organization uses to decide to reduce carbon emission. There is, of course, possibility of enlightened self-interest and responsible business ecosystem. That means not just one business, but the overall industry. And the four aspects talk about Gartner's magic quadrant, talk about any quadrant. People, process, and technology were well known, but we also add the economic factor. And together, economy, people, process, and technologies have to be considered in a ERBS. There are also many standards around, but the most popular, the most well-known is a series of standards called ISO 14000 series. Most of us have heard about ISO 9000 as quality standards. In the past, I remember, landing in Mumbai or Delhi airports from an international flight, and you suddenly find a big board which is compliant with ISO 9001 or 9002. And I was most fascinated by that. Now there is a opportunity to say that a airport or a hospital or a car manufacturing facility, Tata Motors, my favorite, because I used to be a programmer with Telco, as it was called that time in Pune, 1982, which is now Tata Motors. They can all put a banner up saying we are also ISO 14001 compliant. So that's a international standard that some of us need to study and figure out how to apply it in real life. What is it that a organization needs to consider? Of course, buildings, data centers, which is actually reducing now because the large companies, as I mentioned, Amazon, Microsoft, and Google, are offering an IBM uh, data center services so that a bank or an airline need not own a data center. Attitude is important, hardware technology is important, application and systems upgrade, green business process re-engineering, application of metrics and measurement, and legal compliance. That's an area, phenomenal area for management students to work on. And we bring in the drivers, we bring in the dimensions, the risks and the metrics, and then we iterate in order to develop a ERBS for a particular organization. So now that we agree, at least from my side, I have presented that there is a need to develop a environmentally responsible business strategy with underlying basis of artificial intelligence, data science, and there are data sets to be explored and so on, which will help justify, which will help monitor, and which will help optimize the impact of a business activity on the environment. So now the question is, how do we measure? And again, a lot of work needs to be done. I mentioned the ISO 14000 standard, but one of the, well, my exposure to a excellent system of measurement of carbon emission was in Australia. It was called NGERS, which is National Greenhouse Emission Reporting System. It was very, very basic in terms of its logistics, but it required organizations to report their scope 1, scope 2, and scope 3 emissions. So, as I was mentioning, I was giving you the example that in this particular keynote presentation, we have reduced our direct carbon emissions because I did not have to fly, and many of you did not have to travel, use your car or scooters or motorbikes to reach a particular venue. But we have increased scope 2, which is the indirect emissions, and they are not getting measured, and they need to be measured for a holistic approach to carbon emissions. So a lot of data is needed, and not all of that is collected through surveys. But if we can somehow download and study the electricity bills of certain data centers, we might be coming up with some insights that would otherwise not be possible to figure out how we are performing in terms of carbon emissions. So that NGERS workbook had various standardized but various interesting mechanisms, and at its heart, it is just an Excel spreadsheet, but a very, very good one, and I like it. ISO 14000 standard also has to be studied anytime we talk about metrics. So policies, planning, implementation, and checking and corrective actions in management review. And I had developed some parts of this metrics, which I have to now take forward. And they were in two parts, static measures and dynamic measures. I'm now slowly running out of time and I'm monitoring the time. So I have got about 10 more minutes of speaking time or less. So otherwise, I would have loved to take you through this. But if any one of you are interested in doing more work in this space, please do reach out to me. But we cannot just measure carbon in producing a car. We have to measure carbon in producing and in consuming, that is, using a vehicle over 5 years, 10 years, 15 years period. So that was the basics around it. So when a reduction in carbon is matched with the economic drivers of a business, then the cost of optimizing the business processes, virtualizing the data servers, taking people through some sort of training, changing their attitude, all of that becomes relatively easy in a corporate world that is primarily driven by or has the market driven principles, the capitalistic principles. A close synergy exists between a lean and a green business, and lean and Six Sigma and capability maturity models, all mechanisms to optimize and make the business processes lean, have an impact on green. So the reverse is also true, that if we are trying to make a business green, it will also by definition become lean. And a lean business is a more profitable business because it can produce the same output with much tighter business processes. So looks like I have short circuited myself, and I still have a few minutes, but that is what I wanted to share with you. Let me very, very quickly summarize, and then I will stop sharing the screen and see if I can answer any question. See if you have any question. In fact, I might stop sharing now. By the way, this is my email address. I also have a Gmail email address, and I'm on LinkedIn, and I invite you all to connect with me. But let me summarize for you what I have presented. I have argued that with COVID-19, the whole world came under sudden lockdown, which produced some data that pointed to reduction in carbon emissions. That was exciting, but if we look at holistically, then we find that carbon emissions may not have reduced, but may have shifted from one place to another, like in that car with the diesel guzzling car and the other example that I was showing you. I also mentioned this particular keynote presentation in which I may be not producing carbon, nor some of you students who didn't have to travel to the venue, but we have shifted it to the server where the Zoom call is being, presentation is being hosted. And then I talked about the importance of collecting data through metrics in order to justify, in order to study and justify the shift of a business to overall environmentally responsible business. So at any time we apply data science, at any time we apply the concepts and the principles of artificial intelligence to the environmental challenge, then I call it environmental intelligence. And environmental intelligence forms basis of environmentally responsible business strategies. That's all I had to present. Thank you for listening to me. I see there are 55 participants right now, so it must be a nice morning there in India, and it's late night over here. But I will be very happy to answer some good questions. Once again, thank you, and namaste to all my friends.
Thank you, sir, for your valuable talk. I can understand it's late night at your place right now. So thank you again for being here and giving your valuable time and giving such a wonderful talk. Here, along with these 58 participants here, we have participants in the audience. Your talk is projected in the auditorium as well as on YouTube, sir. And with this, I want to say thank you to you and whatever query you will be there, I will be collecting that and will share it
अंकुर
with you. Yes, sir.
अंकुर
Yes, sir, please.
हाँ मैं थोड़ा सा बोलूं
Yes, sir, please.
डॉक्टर भुवनेश्वर दिस साइड डॉक्टर परमानंद
Yes, sir. Namaste, sir.
नमस्ते थैंक यू सो मच फॉर sharing your thoughts and experience with our participants and
Yes,
we
sir.
really enjoy whenever you give your talk and hopefully we'll have such kind of wonderful our connectivity in the future as well. And whenever
Absolutely.
you
I
come
enjoy
across in
it.
India, you are
Yes.
most welcome to come in our university
Thank
and
you.
you can enjoy our local hospitality. You are most welcome, sir.
Thank you.
Thank
I
you.
really
Thank you, sir.
appreciate it. Yes. Namaste.
Thank you, sir. Thank you so much.
Okay. All right. So I am now leaving the call. Thank you to all the students. I could not address them directly, but I can see them. And Ankur and everyone else, thanks for having me. Good night from Florida.
Good night, sir.
I request to all faculty members, please join for the tea at the outside the lounge, please.
पार्टिसिपेशन के आएंगे। Participation. Certificate of participation. विशाल सर चला दिया मैंने.
सोनू यही लगा दे.
The world is here. The world is here.
The world is here. The world is here. The world is here.
The world is here. The world is here at Sharda University. Where are you?
Sun in the sky, sun in the sky, you know how I feel. Birds flying high. Breeze drifting on by, you know how I feel. Birds flying high. Sun in the sky, sun
and making other people aware of how we dress and our culture also.
This chorus is bringing many people together. You get to know their cultures, you get to know their languages, and also make friends with them.
I have a message actually. They have to, also Indians have to try wear this. Very nice.
बच्चों को लिंक भेज देते हैं।
अंकुर सर।
जी सर।
सर ने ज्वाइन कर लिया है।
कहाँ है?
सर वो अंकुर सर वाला वो दे दो तब तक। अंकुर सर का लैपटॉप चल रहा है, लैपटॉप में क्या चला रहा है अंकुर सर ने? अंकुर सर को बैनर चल रहे हैं तो लैपटॉप पे नहीं, अब जुड़ रहे होंगे ना, कोई जुड़ रहे हैं ना साथ में।
मैं एडमिट कर रहा हूँ अब।
Good morning, sir. Am I audible? Good morning, Dr. Andrew. Vishal sir, unmute him.
Hello, good afternoon, everyone. Can you hear me? Can you see me?
Yes, sir. Yes, sir.
Oh, excellent. Great. How are you all doing?
We are fine, sir. Hope you too.
Okay, that's very great. That's good.
We are going to start in 2-3 minutes, sir.
All right, sure, no problem.
Good morning to you all. Today we have Dr. Andrew Keong NG with us. So let me introduce him first. Dr. Andrew is an associate professor with Singapore Institute of Technology. He is the Deputy Program Director of Bachelor of Engineering and Masters of Engineering and Technology in Sustainable Infrastructure Engineering, which focuses mainly on railway engineering and total preventive maintenance. He is a chartered engineer with the UK Engineering Council and serves on committee of various local and international professional engineering institutions, such as IEEE, IES, IET, and IRSC. He is a senior member of IEEE and IES, as well as consultant and advisor of startups and multinational corporations. In addition, Andrew NG is a principal investigator of several grants amounting more than $500,000 Singapore dollars. He holds 1 international patent and has more than 30 publications as both first and corresponding authors. His research and development innovation have also garnered him several prestigious awards such as MIT Researcher Award, Young Investigator Award, National Instruments Editor's Choice Engineering Impact Award. Furthermore, Dr. NG has been frequently quoted and interviewed by news media on railways, transportation issues, and current affairs. With this, over to you, sir.
Yes, a very good morning, everyone. Allow me to share my slides. Okay, before I start, can I make sure that you can hear me and you can see me?
Yes, sir.
Hello. Yes, sir. All things are working properly. Your audio is clear and video is image is clear, sir.
Oh, okay. Thank you very much. I think that is very important
Yes,
because
sir.
I just want to make sure that you capture what I'm saying and
Yes.
you can actually see my slides
Yeah.
clearly. So just let me just make sure that things are doing well. And okay, here it goes. And a very good morning, everyone in India and any participants from other countries. It's afternoon in Singapore here, and a namaste to every one of you. I remember this gesture, namaste to every one of you. And I must thank Professor Prama, Professor Ankut, and Professor Arun for their kind invitations. It is really my pleasure to show and to share with you, an emerging research and development topics on condition monitoring and prognosis, which this topic has been highly emphasized in many industries, such as the railway industries, the marine industries, aerospace, automotive, and even building and construction industries. As early as 2017, the Land Transport Authority of Singapore has announced several strategies for condition monitoring and predictive maintenance. These strategies includes installing the condition monitoring instruments on the new power systems and trains, developing new generation automatic track inspection systems, and using automation technology such as drone or all-terrain vehicles to inspect the tunnel conditions automatically. The year after that, in 2018, the Land Transport Authorities also purchased many new trains with enhanced design and new predictive maintenance features. That these features able to identify any potential or impeding faults for rectifications before they occur. And with that, it increases the railway reliability and safety. The year after that, in 2019, preventive maintenance monitoring systems have also successfully been implemented to detect any abnormalities in power, trains, and track equipment. Trains that are undergone mean-life refurbishments have also new condition monitoring systems to assist the system's performance and also to improve the maintenance planning. Not just in Singapore, in India, which we know that the Indian Railway is the 4th largest railway network in the world with nearly 70,000 kilometers of track in the year of 2019. And now I believe it is more than 70,000 kilometers of track. Similarly, the Indian Railways also attempts to employ artificial intelligence, the AIs, for predictive maintenance. They installed multiple non-intrusive sensors on the trains, on the tracks, could continuously collect the data to understand about the system's health. These data are analyzed to predict any potential failures in real time, which allow the maintenance staff to repair and to replace before the system failures. Not only that, in 2018, the Indian Railway purchased quite a number of smart coaches with intelligent sensors-based systems to monitor the train's health, as you can see from the reports. And this year, in January, in fact, just probably last month, the Deputy Chief Signals and Telecom Engineers at Indian Railways appraised the smart approach in shifting the asset management regimes from the very periodical, very conventional, very traditional maintenance approach to a new approach which is more towards condition monitoring and predictive maintenance. This predictive maintenance, as mentioned in her articles, it offers many advantages. For example, it helps to improve the reliability of the systems. It improves the availability of the systems by reducing the mean time to repair and to increase the mean time between failure. It reduces the maintenance and operational efforts. It brings collaborative working environments with original equipment manufacturers, and it also helps to make data-driven decisions. So you can see that there are a lot of advantages of having predictive maintenance and condition monitoring. So what is actually condition monitoring and predictive maintenance? Based on the British standards, condition monitoring is known as activities which can be performed either manually or automatically with the intent to measure at a predetermined intervals the characteristics, the conditions of the actual states of an instrument. Unlike the inspections, monitoring allowed us to look at the conditions of the systems of the equipment in real time. Condition monitoring is actually the heart of a condition-based maintenance. Put it simply, the maintenance is done based on the conditions of the equipment. And when we carry out this condition-based maintenance based on a certain forecast that's derived from repeated experiments, repeated analysis, or some form of predictive models, then it is called a predictive maintenance, where the maintenance is done way before the systems fails, based on some form of predicted models that we have derived from repeated experiments. So this is a bathtub curve that shows the component failure rates over time. This curve can be broadly classified into 3 distinct periods. The first period is the infant mortality, or sometimes they call it as an early failure, with decreasing failure rate. As you can see from the curve very clearly that there is a decreasing failure rate. Then the second period is known as the random failure period with very constant failure rate. And the last distinct period is the wear out period, where the failure rate increases. And what causes the failure rate to decrease in the earlier stage during the infant mortality period? This is largely due to poor design, poor installations, or misapplications. In the second period, where this random failures period comes in with a constant failure rate, this is largely due to poor maintenance and operations. And the last part, the wear out period. This wear out period is due to the expirations of the design lifetime, the component lifetime. So studies have shown very clearly that if proper condition monitoring and predictive maintenance approach are carried out, we would be able to expand the service life of the equipment. That is to say that we are able to extend this random failures period. And this is evidenced in this potential to functional failure intervals, where you can see clearly that if we have proper maintenance-based methods, such as the use of vibrations analysis, oil analysis, we are able to move the points, which is these potential failure points, up to the curve, extending the period of the P-I, which is the potential to functional failure. That says that the equipment lifespan will be extended if we have proper condition-based maintenance and predictive maintenance. So monitoring of condition of the track has been increasingly important over the past decades. It was because of the high traffic index, high riderships. So we want to facilitate to make sure that the transportations is reliable, it's safe at all times, and also to reduce the overall operational and maintenance costs. Studies have been done and surveys has been conducted to 16 infrastructure managers in Europe. These are the parameters that they have identified as important for track condition monitoring. And these parameters includes the track geometry, the rail profile, the rail cracks, the rail temperatures, the geometry of the switches and crosses, the presence of the rail fasteners, so on and so forth. So these are the parameters that the railway industries, in particular, the permanent ways, the track, departments would want to monitor as real as possible in real time. So let me talk about the track geometry measurements. Track geometry measurements are usually done by equipment such as a multifunctional vehicles or a handheld trolley. So what is a multifunctional vehicles? In order for me to explain the multifunctional vehicles, I would like to extract a video from the network rail to tell you more about the multifunctional vehicles. So please sit back and take a look at the videos.
This is the Railway Technical Centre in Derby. It's where we at Network Rail house our fleet of 9 infrastructure monitoring vehicles. We use the vehicles to test pretty much everything there is to test on the network, from the overhead wires down to the ballast on which the track sits. We carry out monitoring in order to predict and prevent track faults occurring. The workhorse of our monitoring fleet is the new measurement train. It surveys our entire mainline network every 2 weeks, covering over 110,000 miles a year. The NMT is a modified high-speed train. Rain or shine, it can record track at speeds up to 125 miles per hour, allowing us to work during the day with minimum impact on passenger services. The NMT's array of sensory technology make it the most technically advanced train of its kind in the world. Transducers and accelerometers mechanically measure the up and down movement of the train as it travels along the rails, giving us information on track geometry. As well as mechanical devices, the NMT also carries optical instruments. This laser sensor gives us vital profile information on the rail head. A new expert system called Plane Line Pattern Recognition is currently being developed on the train. It employs a series of lasers and cameras with image analysis software to automatically detect faulty track components as a train passes over them. All the NMT's sensors, whether mechanical or optical, feed their information into the banks of computer equipment on board, which are in turn monitored by our on-train crew.
One of the primary objectives of the new measurement train is recording the track in a digital format. We're looking for 3 main types of defect. There's twist. This will be where the 2 tracks are no longer parallel and one of them has dropped slightly or raised slightly. This would give the train a tilting effect as it goes over. If this was allowed to carry on far enough, you would derail. Next on top of that, we're looking for a defect called cyclic top. That is where the train basically starts a small bouncing movement. As this happens and various trains go over it, it gets worse, and it gets worse with every train that passes. Eventually you'll find that a freight train will pass over this and its suspension isn't as sophisticated as, say, a passenger train. What will happen then is this freight train will go over and eventually bounce off of the tracks. Last of all, we're looking for gauge. Gauge is the width of the track. What you'll find is in places that things aren't quite as they should be, and the track might get a little bit wide or a little bit tight. Generally what happens there is we'll monitor it and we'll never let that happen. On the new measurement train, the simplest way of explaining this job is we're converting all the features of the track into just a digital format. Basically ones and zeros. The new measurement train covers all of the main routes. These are the main arteries, if you like, of the railway network. I always find it a constant source of amazement how many miles we can cover in a day. Some of our shifts are up to 1,000 miles long. On this vehicle we've got around about 40 sensors. They can range from LDBTs, lasers, gyros and accelerometers. They're constantly feeding information into computers here behind me. That's then displayed out on these monitors. What we'll generally do is, throughout a shift, look for any serious defects. Any of the minor defects are also monitored in the background, and any defects that are found are stamped with a GPS location, making it almost pinpoint accurate for the engineers to come and rectify. At the end of a shift, we'll then package all that data to EDC, which is the engineering data, where the information is processed further. Train's capable of testing at 125 miles an hour. That's on all systems. Initially, I got the job about 10 years ago. My previous employment, I used to be a non-destructive test engineer. Non-destructive testing is quite simply testing anything without destroying it. It's non-intrusive methods of inspection, i.e. looking through things rather than cutting in half to see what's there. With the new measurement train, we're doing a form of non-destructive testing at high speed. Computers make a massive difference to the job. There isn't a day go by where we don't look at a screen of some form or another. The automated analysis that the vehicle does on its own allows us to not have to block the lines. It allows trains to run freely in front and behind us. Today we're recording around about 130 miles. It would take hundreds of men to just record that. The clue's in the name. New measurement train is a test bed for new monitoring equipment. We have two vehicles on the train. There's a production vehicle, which core job is to do the track recording, and the development vehicle, which we do test out very new systems on. If there was a fault serious enough to block the line, we'd instantly tell the driver. He would then stop the train. This would then not only block the line with our presence on the track, we'd then go and tell the signaller of what needs to be done, and then we would continue testing. Many of the other faults we find tend to be scheduled into the maintenance regime. On the front of the train we've got HD cameras. It's such an effective way of monitoring the track without having to come out and investigate in person. The new measurement train is definitely the best train we've got in our fleet. It's the fastest, it's got the most equipment, it covers the largest distance in any shift, it's somewhat of a legend. I love my job for many reasons. Firstly, the scenery out of my window is always different. It's far better than turning up to an office every day. Secondly, I'm on the cutting edge of technology. We get to work with systems worth millions of pounds. Last of all, I know that I'm making the railway a safe place to be.
Okay, welcome back. I hope you have a better understanding of a multifunction vehicles. So we can see that a multifunction vehicles has a variety of sensors, measuring systems, and data management systems in order for them to create the profile of the track and also able to inspect the track accordingly. And some of the common sensors that we can see are the laser sensors to measure the rail gauge, the cross level, the rail profile, and wear. They also have the accelerometers to measure the vertical track irregularities. They have the gyroscopes to look at any presence of obstacles. They also have video cameras to capture the track video images. Apart from the multifunction vehicles, we also have a rail push trolley, or simply a hand push trolley, to inspect the rail, more localized area, and other track side railway infrastructures. So these are some of the examples of track inspection trolley that you can find in the markets. And allow me to just show you a clip to share with you what a hand push trolley is about. So this is an example of a hand push trolley. You can see a difference between a hand push trolley and a multifunctional vehicles. A hand push trolley is usually smaller in size, and it operates at a very low speed. It's in fact at a human walking speed of about 1 meters per second, and it has dedicated software, and it only comes with a few sensors to specifically measure, the surface defects. So apart from these two equipments, we have the multifunctional vehicles, we have the track inspection trolley. Those are the common equipments that use to measure the track measurements, to measure the track configurations and the track geometries. So real defects detection is also a very important aspect, as important as the track geometry detections, because the rail plays a critical role in a railway systems. As we know that the rail, the tracks itself, actually, the rail itself supports and guides the train, which transport people, goods, animals from one place to another. So if we have any defects on the rail, or if there are any broken rails, then there will be a lot of detrimental consequences. For example, train may derail, train may collide, and this will cause a lot of devastating effect. So rail defects itself can be broadly classified into two types: the rail internal defects or the rail surface defects, as you can see in this table here. So these rail surface defects can be again broadly classified into two types: a rail contact fatigue driven surface defects or rail corrugations. Example of a rail contact fatigue defects are the shells, the squats, the checks, and the spalls, as you can see from the diagram below. And rail corrugations is different, from the way it appears, because it is an undulating wear. It is a quasi-periodic wear that's run on the rail surface. So there are a lot of studies, research group in the institutions, in the education sectors that wants to automatically detect the rail surface defects. Allow me to go through some of these papers that have been published on the rail surface defects. The first one that I want to share with you would be this Spanish research groups that tries to detect squats using two accelerometers to measure the vertical accelerations. So using very simple processing techniques such as short time forward transformations, they are able to detect, track singularities and any presence of defects on the rail surface. Next, we also have another groups that from Dutch in the Netherlands that tries to look at images of the rail surface using deep convolution network. They are able to detect 92% of the squats correctly. And in quite a recent studies in 2018, where these Dutch teams tried to merge signals data and image data together to form better decision. And with this merging of data, they are able to increase the detection accuracy while reducing the false alarm. Next, Japanese teams in Japan actually developed an onboard sensing systems where these systems contains microphones, accelerometers, gyroscopes, and the GPS. This system itself will be placed on board in the cabin seats where they measure the cabin noise. And in their studies, they found that cabin noise are higher when the train's cabins runs over a corrugated rails, as you can see from the graph over here, where the top one shows the cabin noise and the below plot shows the spectral peaks of the cabin noise, where the gray areas are the areas where the rail surface are corrugated. Corrugated, you could see it as roughed, where the rail surface are very roughed. So in 2013, the China research teams adopted the fiber laser accelerometers, which is a very sensitive accelerometers to detect the correlations between the acceleration signals and the corrugations on the rail surface. And they see quite a good close relations between the acceleration signals and the rail corrugations amplitude. I'm very privileged to have these opportunities to work with the land transport authorities and the rail operators in Singapore to develop and to understand the rail corrugations for condition monitoring and prognosis. So in my studies, we developed a 3D dynamic rail-rail interactions models to depict the rail actual conditions when the wheel runs on the rail. So this 3D dynamic interaction models is showing you how the wheel will interact with the rail on smooth surface. We also collected the acceleration signals as the wheel runs on the rail. Next, we try to corrugate the rail surface with 30 mm wavelength rail corrugations, and we can see that the amplitude of the accelerations increases when we make the rail surface rough with corrugations of 30 mm. As we increase the wavelength of the rail corrugations, we realize that the amplitude of the acceleration signals reduces. But these reductions in the amplitude is still higher than the amplitude generated from the smooth rail surface. So this is a plot that shows you the acceleration signals and its corresponding power spectrum density for three types of rail. The rail which has a wavelength of 30 mm, which is in red, a corrugated rail with a wavelength of 80 mm, and a smooth rail. So in this time plot, a temporal plot, we can see clearly that the acceleration signals amplitude increases when the wavelength is at 30 mm. From the spectral plots, we can also see that this corrugated rail with a wavelength of 30 mm would generate dominant frequencies in the range between 400 to 600 Hertz, or in particular, about 500 Hertz or below. Then we try to look at the wear depth, not just only the wavelength, we also changes the wear depth through the Achat wear law. And through this modeling, we see very clearly that when the wear depth increases, the amplitude signals also increases. This is shown in the third iterations on your right hand side, where the mean wear depth is approximately 0.1 mm. As compared to the smooth rail, you see clearly that the acceleration signals amplitude is very low. When we transform it into the frequency domain, using the time frequency plot, we can see very clearly that the rail corrugations appears as a horizontal band across a very specific frequency range. in the range of about 200 to 600 hertz. And this frequency range is quite consistent if the wear depth and the wavelength remains constant. And with this understanding, we process rail signals that is captured from 2 railway stations in Singapore, the Pioneer stations and the Boon Lay stations. So we can see that the corrugations occur severely at these locations as compared to corrugations at the earlier locations by looking at the color, or which corresponds to the magnitude of the signals. So that is to say that we are able to identify the locations and the severity of the rail corrugations, and with these identifications, it can assist us in our maintenance planning and resource allocations. Not only that, we are able to do some form of prediction to understand what is the growth rate of rail corrugations when there is a change of sleeper distance from the existing 700 mm to 500 mm. So in this prediction model, we see very clearly that as the sleeper distance reduces from 700 mm to 500 mm, there is a drop in the growth rate. That is to say that rail corrugations will grow slowly as the sleeper distance reduces from 700 to 500 mm. And this is because we actually increase the damping. Once we increase the damping, as the sleeper distance reduces, it reduces the vibrations and the dynamic stress between the wheel and the rail. And because of these reductions in the dynamic stress and vibrations, the acceleration signals reduces, and correspondingly, it also reduces the growth of rail corrugation. And this modeling is very important because it allowed us to make informed decisions about the design of the track. It also allowed us to make useful decisions about the growth of rail corrugation, which can be easily translated to scheduling of our maintenance staff and maintenance activities on the railway tracks. So you can see that these are the studies that we have done, from modeling, simulations to analysis and predictions of the rail corrugations. And of course, there are many railway infrastructure conditioning monitoring projects, in the world. These are some of the projects that are done, mainly in the University of Birmingham, with other universities and other train operators, in Europe. So this is about a real-time forecasting of the flood. And this is about the track remote condition monitoring. This is track circuit condition monitoring. This is track circuit condition monitoring again. This is human movement or human intrusion detection systems. And this is the landslide monitoring systems. And this is on the crossing and the switches monitoring. And this is the railway monitoring using fiber optic sensors. And that comes to the end of my presentations. I want to take this opportunity to thank you for the opportunity given to share with you this topic on condition monitoring and prognosis for the railway tracks. And I hope that you enjoyed it and you learned. And I seek future collaborations with you, if possible. And apart from that, I'm also the guest editor for the Census Journal. which is a prestigious journal with an impact factor of 3.275. In these special issues, we will be looking at the advanced sensors technologies for condition monitoring, predictive and prescriptive maintenance. So look forward to your manuscripts and your submissions. Thank you very much. That's all for my presentation. Thank you. And this is time for question and answers.
Yeah, thank you, Dr. Andrew. Thank you for being here and enlightening us with your words of wisdom. Dear participants, if you have any question, you can ask in the chat box. We will read it for you. Participants, if you have any question, you can ask. Yeah, thank you, Dr. Andrew. I think there is no question from the participants.
Thank you very much.
Yeah.
Thank you.
Yeah, thank you for sparing your valuable time, sir. Bye-bye, sir. We are going to end this meeting now.
A question tha na. Hello. Sir, I think there is a question from Mr. Vishal. He has raised his hand in the chat window.
Yeah. Yeah, Dr. Vishal, kindly read it.
If any participant have any query or question, they can unmute yourself and then ask the question.
Participants, you can unmute yourself now. If you have any question, please ask.
Yes, feel free to let me know if you have any questions. I'm more than happy to address your questions.
Yeah, no question, I think. No question.
I have a
sir.
question.
Yeah,
Sir,
please ask.
how do you convert the images into spectrogram as you shown before, sir?
Okay. Okay. How do I convert the signals into the spectrogram? Are you referring to that?
No. Images into spectrogram.
Images to spectrograms.
Yep.
So images, we have the image processing methods, and spectrogram, it's I'm not too sure which slides you are referring to, but for spectrogram, we are looking at time frequencies. Therefore, we are using signals. We use signals, acceleration signals, and convert that acceleration signals to the spectrograms using very standard, time frequencies analysis method.
Okay, sir.
Yeah.
Thank you, sir.
Yeah. Anybody else? Any other question? I think no. Thank you, Dr. Andrew.
Thank you very much, and bye-bye.
Bye-bye, sir. Bye-bye.